So we're talking today with Scott Edgington. Thank you for joining us.
You're welcome. It's a pleasure to be here.
So tell me, what was the first question you had when we were checking out his bio? Do you recall?
What is a planetary scientist?
So a planetary scientist is a scientist who studies planets in our solar system and in other solar systems. The background of that scientist could be chemistry, could be physics, could be geology. Many different types of sciences feed into the discipline of planetary science. As a planetary scientist, we're interested in studying atmospheres. We're interested in studying the surface of the planets, the interior of the planets, how they form. How did they form 4 billion years ago when the solar system, was created? And then others. Extrasolar planets will tell us something about how those systems form, and is there a pattern? Can we figure out that pattern? So there's a lot of different aspects.
But never having been there, like I'll say Jupiter and Saturn, for instance, where nothing that we have made has landed on the planet unless it's crash landed.
That is true. Yes.
How do we know? How do we know what to study? Like how do you know what the atmosphere is if we've never actually been there and taken an air sample?
So let's go back in history. The ancient Greeks, they observed the planets by looking at points of light in the sky, and they noticed that certain points of light moved, and that's what they called planets. The ones that they knew about, the big ones, Jupiter, Saturn, easily observed in the night sky. But there's always that question, what is that? And over time, we figured out, the Earth isn't in the center of the universe. It's not even in the center of our solar system. The sun is. And so we learned things like that. Over time, we got into what I would call spectroscopy, electromagnetism, which helped us to start identifying things. Everything has a fingerprint. Every molecule has a signature. And by looking at the spectrum of light, you get an idea of what is there. It doesn't tell you the whole story of what is there, but if you observe in enough wavelength regions, and then you apply your knowledge of physics, gravity, electromagnetism, various chemistry that you've learned over time, you start piecing together the puzzle. And over time you learn things like, Titan has a nitrogen atmosphere. What else has a nitrogen atmosphere? Earth. There's some similarity there. Let's take a deeper look. There's methane there. Well, Earth has methane. What other things can you see there? We see chemicals here in the atmosphere, we see chemicals there in the atmosphere, the same chemicals. How do those chemicals get formed in those atmospheres? Here, we're a lot closer to the sun, it's warmer. There, it's colder. But what is common amongst them, and how could we apply our knowledge of physics and chemistry as we know it? Just fascinating field.
You recently started studying physics. Didn't you? There's an Intro to Physics book, is it not?
Yeah.
Okay.
It's labeled physics.
Is it not physics?
Physical.
Physical science.
Okay.
Okay. I was going to comment. I teach high school now. Currently, what project are you engaged with?
I currently work on the Mars Perseverance Rover mission. This is the mission that it landed 2 years ago on the surface of Mars. And during the height of the pandemic, quite the achievement to do that. We landed, we've been driving around on the surface, looking at geological features, and our primary goal of the mission is to collect samples. Think of it as test tubes, on board, and we have a drill, and we basically drill into the surface of rocks, into the ground, and we collect those samples. And the goal of collecting those samples is to get enough variety of things there, like, okay, is this sandstone? Is this limestone? What are these rocks made of? And get as much diversity of the geologic features as we can. And then a future mission, someday maybe your generation will launch a mission to go and retrieve those samples. And there's actually plans being in the works to build that mission and to collect those samples.
So in theory, the test tube samples that are on Mars now that were pulled up from Perseverance, they're going to stay on the surface for a decade, maybe 2 decades, until the next generation can design something or send something out there to grab them? Is that correct?
Well, hopefully not decades. This mission that they're designing will tentatively launch around 2030 timeframe. And that mission will get to Mars, land on the surface, and over the course of, I think, about a year, it will collect the samples from the rover and put them in the nose cone of a rocket and fire that rocket back to Earth. And the European Space Agency is designing a mission to grab those samples once it's off of Mars and then bring it back to Earth and eventually drop it into Earth's atmosphere, and somewhere in the Utah desert the samples will land.
Really?
Yeah. Mm-hmm. Yes.
I guess, how is...
So this is in your lifetime.
The European Space Center is going to catch the nozzle in space that is sent from Mars.
Yes.
And it'll be like a space station will grab it or something?
An orbital mission that they are launching. So they're building their mission or designing their mission now that will be able to go and retrieve it. We're very good at docking with things in Earth orbit, for example. You have the space station docking with capsules all the time. It's not inconceivable that you could send a satellite there to get to Mars orbit and say, okay, there goes the rocket, I'm here to catch it. Yeah. So
now, I guess one final point on that. How will the vehicle that's on Mars, once it has the samples, how will it propel itself from the surface of Mars?
It's going to have fuel, of its own, and it's going to. You could actually find a video of this online if you go to jpl.nasa.gov. Look for Mars sample return. It will literally launch from a horizontal position. Think of it as a spring-loaded device that will just toss the rocket up. We fire the rocket once it's levitated in the air, and off it goes towards the horizon, and it's probably a lot easier to launch from the surface of Mars just because gravity is not as much of a factor, and atmosphere is also not that much of a factor. And so on Earth you have to worry about, you have gravity to overcome, you have atmosphere that is slowing you down, and so you need enough punch to get up there out of the atmosphere and into orbit. It's going to be a remarkable achievement, though, because it's the first time we've ever done that on the surface of any planet. Yeah.
Perseverance, that's the vehicle that had the Mars helicopter, is that correct?
Yes.
Did that Mars helicopter glean any information that was, I hate to use the cliche, out of this world? But that's such an alien thing, isn't it? To send something up there and then have a little helicopter that could go do roundabouts. Did the helicopter tell you anything?
Well, so the helicopter mission itself was a proof of concept. Can this work? And we understand how to fly things in Earth's atmosphere. We understand fluid mechanics and the equations that govern fluids. And so it's not inconceivable that you could fly something around in the atmosphere of Mars. This was a test of that. So they designed it. They actually designed it to fly just a few times and see if it works. And what can we learn about the concept of flying there? Maybe there's some things we don't know about, and so which would have made it difficult to fly.
How can it? I mean, is there gas that's going to be pushing down on it? I guess. Yeah. But you guys knew all that. You guys, you Mars people, you knew that.
Well, I mean, we know the basics, the physics. We know what the atmosphere is like after observing it for 50 years. We have fancy computers these days that could help us simulate the fluid flow around blades and etc. But there's the fact that it hasn't been done, and just like the Wright brothers, it's like they knew something about Earth's atmosphere, and it took them many times to, this should work. However, it's not working. Why isn't it working? Well, maybe your device isn't designed right, and they had to tweak their design in order to get to the point where they could fly, and so there's always the potential of some unexpected thing like that. That helicopter has now flown 56 times.
Is it still?
It was designed.
Is it still working?
Yes.
It's still.
Yeah, it's still flying.
Serviceable.
Yes. Yeah. We use it as a scout now, since we've shown that this is going to keep going as long as we provide the energy to it, which is solar powered, and as long as we don't crash it into anything, and so we use it as a scout. It goes ahead of the rover, and it looks at the ground and says, there's some boulders over here, there's some flats, some sand dunes over here, and we get an idea of, with this rover we could maybe go in direction A or B. This looks more interesting over there, so that helps guide us.
Smokey and the Bandit.
Previous to that, all we had was satellites that, Mars missions that have cameras that look down on Mars and map the geology, but it doesn't give you that close view of the surface. The helicopter does that.
So it's like a helicopter going ahead of the scout?
Yes. Mm-hmm.
Like, is it in the air or on the ground?
It's in the air. So we send commands to it. It will vertically take off, horizontally move some distance, and we have enough information to know that from a satellite, we want to go over there.
And then the rover follows it.
And then the rover, yes, will follow along after we look at those images. It could turn out that that's not interesting. Let's go over there, and so we'll.
Do you control the helicopter and the rover?
Mm-hmm. Yes.
Is it in real time, or is there much of a lag?
There is a lag, yes. So just to get a signal to Mars, it takes about 8 to 10 minutes.
Okay.
So it's not instantaneous like you're playing a video game. So there's that. But there's the planning aspect. We have what's known as ground in the loop, which means that, you have information, and you retrieve that information from whatever data you got the previous day. And from that information, you design your computer sequences to do certain things. Like the scientist might say, hey, I want to look at this with my stereo camera, or I want to use the arm of my rover to get a close-up of that boulder. And so we design sequences to do that. Basically simple computer programs that says move arm here and place camera there.
What is a stereo camera?
Stereo camera, that gives you 3D information. So you have two eyes. You have two eyes. You use your eyes all the time to get information that tells you that something is 3D, like this.
Yeah, this microphone.
Microphone. If I just had one eye, that's a flat 2D surface. But if I have two, you have data coming in that tells you, it looks differently from these two different angles. And so that's what we call stereo camera. So the rover has two eyes
so
that
you can
it
tell
could
the
use
depth
to...
of the rock, if it has any crags or whatnot that are hiding aliens or whatever.
Yes. And you could tell, that rock is close, and that mountain over there is like a kilometer away. The resolution is...
And the perspective, it gives you the perspective that you would otherwise be lacking.
Yes.
That makes perfect sense.
Yeah.
When you started at JPL, do you just go in and you say, I'm a scientist. I know a lot about I know a lot about this, or do they say we're working on a Mars project and they assign you? How does that work?
Well, okay. I mean, just to get to JPL requires years of school. In my case, it was 5 years of college and 5 years of grad school, studying, in my case, engineering physics as an undergrad, and planetary, atmospheric and space science. It was my graduate degree.
And you went to school where?
University of Michigan.
Okay.
And Pittsburgh. So my grad school was Michigan.
Okay.
And so after that, I get my PhD. I find a professor, scientist, who was at JPL to work with. I applied for the position and kind of interned with him. And after that, I was like, okay, this is a really cool place to be. I want to stay here. And so I looked at the job listings and saw, and talked to people. Networking is very important. And so a friend of mine who I was sharing an office with gave me an idea that, hey, this job would be ideally suited for you. It involved studying Saturn's atmosphere at the time. My main specialty is the Jovian planets, Jupiter, Saturn. And so, this mission is going to Saturn. We're gonna, we need scientists and engineers to basically tell the spacecraft what to do when it gets to Saturn.
And how far out do they plan these things? So you heard this 5 years before the mission, 10 years before the mission? What kind of scale?
Let's see, I joined the project 4 years before we got to Saturn.
Okay.
It was on its way. We had just passed Jupiter, I believe. And it was 3 years from Earth. So, it took 7 years to get there. It takes a long time to do planetary science. It's literally a lifetime career, so to speak. I was on that project for like 12 years. Yeah, 12 years of my life. Actually, more than that. Just an amazing mission. And then after that, I was looking around for other things and did a little science on my own. But then I found the Mars mission program, and they were looking for people who had similar skills. Like, okay, you're used to planning science, on a spacecraft. And that takes certain management skills because, okay, you have to be able to look at things like, okay, what's the data flow? What is the energy that we have available? How much fuel do we have for something? And so you have all these constraints that you have to fit the science into. And you don't want to be, for example, planning to do something when you don't have the energy to do it. That's just not going to work. And so it's like a puzzle you're putting together. It's like, okay, well, how if I put it together this way, will that get us the science that we want?
There's one thing we've learned this weekend is that the science and the engineering behind outer space, they don't have different objectives, but they have different means to the same objective because it's fascinating to think of. Never thought.
Yeah.
You want to add anything?
No, I don't have anything to add. Let me see that to you.
Okay. For me, the scariest part about space is...
Did you
have a question?
What you got?
So when you sent the helicopter for the routes, it became a scout, and then you used it for navigating the rover's way to see if there's anything interesting over here.
Yes.
And does the rover also collect like samples and sample tubes?
Yes. And so we'll take the rover, we'll tell it, okay, we want to go over there, and it will find its way through whatever terrain, And as long as we don't encounter barriers that are bigger than the rover, we could drive over rocks, for example.
So does the helicopter carry the rover back to Earth?
No, the rover and the helicopter will remain on Mars, and
They will never leave.
they will not leave unless humans someday in the future goes and picks them up
It'll
and
be
put
in some
them in the
museum
museum. Yeah,
like, hey,
right.
This is perseverance.
But we do the same thing with the moon. We land things on the moon. We really can't bring them back to Earth. They just sit there, and who knows how the environment will change them over time.
Is the procedure of getting to Earth hard?
You mean from Mars? Yeah.
From Mars?
From Earth to the moon.
Oh, getting from Earth to the moon?
Yeah. Is it like difficult?
Yes. And I say that because it takes a lot of money. It takes a lot of people power. It takes a lot of brain power to figure out how you're going to do this. Back in the early days of the space race, it took us, let's see, we launched like 7 missions to the moon. It took, I believe, we failed 5 times getting to the moon. This is with 1950s technology. And on the 6th try, we actually landed on the moon. You would think it'd be, oh, the moon's right there. Just launch something over there. It's not as simple. Now we've, over time, you get better at it because you learn things. And now we could send something and land on the moon.
When you were their age, when you were their age, did you want to go to space? Are you always curious about it, or was this a happenstance because of your mathematical abilities?
I grew up watching shows like Star Trek, Lost in Space, which always was there for me. As I went through school,
Like our neighbor.
yeah, I'd like to hear what your neighbor did.
How do you been to
Similar
space?
Yeah. Okay.
How do you been to space?
Have I been to space? No. No, I don't meet the qualifications that an astronaut would need to go into space, and I'm not famous enough to buy my way into space. Yeah.
So it costs like over $1 million to go to space?
I don't know how much it costs for SpaceX or Blue Origin to
$250,000.
send you.
Do you think humans will live on Mars?
I think a future generation of humans will go to Mars. I think they will try to live on Mars, and hopefully they'll survive. I think personally we should do the moon first because it's closer.
Live
We could-
on the moon?
Yeah, I would love to go to the moon.
We would be on Mars.
I think your generation will likely launch a mission to Mars
A man.
with humans. Yes,
Okay.
yes. If I hope I live long enough to see that. I don't know if I will, but I do hope that I start to see structures built on the moon. Though we have a mission coming up that's going to land people on the moon in several years. It's called the Artemis mission.
So you have a mission
yeah.
of so you have a mission of people landing on the moon?
That's upcoming. The
Like
Artemis
in
yes.
several years.
Yeah, in several years. The Artemis mission, what's going to be unique about that is it's going to be all female landing on the moon. Because in the past, no females have landed on the moon. Yeah. So.
So in several years, they're thinking of sending females to the moon and trying to live there.
I don't know the details of the mission, what their ultimate
But they already
goals
have
are.
a mission.
They are planning a mission, yes. Yes, they're training the astronauts.
so-
Hang on, we have to wrap it up.
Yeah.
He's got a busy schedule. In theory, to motivate either by curiosity or any means, what would you say to students who may want to pursue a STEM career, but they may be intimidated by its perceived difficulty? What could you say to that?
I'd say do something that you love to do. And you don't have to be a math genius. You don't have to be a physicist if you don't want to. You know, many career option types will feed into being a scientist, being an engineer in the space program. You know, we need all people with all types of skills.
Designers.
And yeah, it could be, you know, you're designing the computers that will eventually fly on this spacecraft. You know, we need all types of talent. Do what you love to do, you know, and the rest will come. And if you happen to be good at math, great. I'm good at math. I love it. You could see my shirt.
I wish I had that for my classes.
Well, you mentioned you teach English. That's so important because people like me need to write papers to publish in journals. We need to write proposals and sell the science that we want to do. You know,
You're very
and
approachable.
so
When you talk, we can understand you. And there are some scientists who you really got to delay things for 3 seconds and then say this is what they said, run it through some translator internally. But when you speak, I can easily understand what you're saying. So I think that's a fine attribute.
Yeah, read more, you know, and pursue your passion. You know, you're going to have some passion, and who knows what that's going to be. And it might lead you to the space, to the moon. You know.
Are you based out of California or Huntsville?
California.
Okay.
Jet Propulsion Lab.
Okay.
Yeah. I'm here with a number of colleagues actually from JPL, and we all give talks on the space track, which is, in my opinion, a very fun track to go to. You know, has a lot of working scientists, working engineers, talking about all types of subjects related to space, not just Mars, not just, you know, one thing, but the whole variety. Yes. Yesterday we had geology talks. You know, there's people talking about companies that build rockets that, you know, help the space program along. So I highly recommend that track if you're interested. There's also a science track if you're interested in that, and there's also a skeptics track.
Yes.
It's always good to have a nice foundation of logic and skepticism, you know, in today's world of misinformation. You know.